Okay. Do you want to just use my?
Thank you. Okay. So we've been having all these sporadic discussions about Nova, placement API, resource providers, and whatnot, right? I'll try to put them all together in one place. So we'll talk about our basic model of what FPGA looks like. It's not necessarily any one implementation today, how we can model it for now and for the future, and how we are going to use FPGAs, like programming models, how we can do it in cyborg, scheduling issues, and image management issues. Okay, still messed up. Okay, even after conversion to PowerPoint, still not good. Okay, that's fine. Okay, I'll fix it later.
You might have opened the presentation instead of the PowerPoint.
Oh.
So you may need to go, Howard, and go to your shared with me section and download the PowerPoint.
It's there in the chat, right? If you go to the chat area, like, okay.
That's the one I got on my phone anyway.
Yeah, we're on the.
You go to the Etherpad.
Yeah, the Etherpad. There's a download.
Yeah.
Search. Yeah, PTG Etherpad.
No, I know what they are. It's still.
这也不是白牌，就是 Mac
你是
自带的，
PowerPoint?
可能会好一点。
Especially
Yeah, this looks like it.
because they're not linked.
Yeah.
Okay. Go to docs. Go to docs.
Because I was just.
Exactly.
没装
See that?
盘
Wait a
吗
minute.
Sorry,
You can't know.
no, it's
There's one in Etherpad.
This
it's
looks
better. It's better. We
Okay, that's fine. We'll
Yeah.
Okay.
I didn't have PowerPoint from
Talking about Nova.
No,
not this one.
no, that's search. Just the link.
So I usually click on the installation docs and it takes you to the right place.
Guys.
Oh, view the docs.
It wasn't there a while ago.
Right, specific guides or admin guide.
Admin guide, yes.
Okay, open the same thing.
Or
Google
the
Slides.
It actually doesn't matter because once
So
you
instead of
get
opening
there,
Google
it's
Slides,
fine.
just leave it as it is.
Yeah.
Oh, it's still broken. I see. Okay. Okay.
What did I just type?
That's because fucking companies.
Yeah.
They started to launch all the project specific installation.
That's fine. That's
Yeah,
that's fine. Okay. Okay. Anyway, yeah, you can use my laptop actually. You can see this. Oh, you are running.
That's my favorite.
You cannot use my laptop.
You can join the Zoom meeting and you share.
And then you can go to
Too hard.
the.
That's fine. We'll just talk through this thing. Okay. So our general model of FPGA is composed of one or more regions. So typically FPGAs have partial reconfiguration support, right? So each such region will be a separate unit of programming. If the FPGA does not support PR, we'll say the entire thing is one region. So generally FPGA is composed of one or more regions in a tree structured fashion. A region may contain one or more accelerators in general. So for example, we put only one image in a region, but let's say the image contains multiple, let's say compression cores, like Z-like cores, for example. You may want to assign each of them separately to a VM in general. I'm not saying we are doing any of those today, but we could. So in general, we don't have to preclude this model because it fits still anyway into Nova's existing hierarchy. So a region may contain one or more accelerators. And FPGA may have local memory, even of different types. So for example, you may have DDR, may have HBM, may have different kinds of memory potentially. So we can model all of those. One constraint which I'm adopting is that an image may only be applied to the region type for which it's synthesized. So let's say you got one FPGA, two regions, and both are identically sized. Still, if you generate an image for one, you should not apply it to the other one in general. There could be exceptions for that. You're saying the same page, right?
Yeah.
Okay, cool. Okay. So there could be exceptions to it, especially as you go forward. However, this is the least common denominator among all devices today. So generally, it's up to the software to take care that you don't apply the wrong image to the wrong place. That's the importance of metadata, which I think we're going to talk about tomorrow. So there are different ways you could use FPGAs. So we have talked about several times: pre-programmed, orchestrated program, user programmed. At a high level, you could say that if the FPGA already comes pre-programmed, or the orchestrator is doing the programming for it, from the user's point of view, you're simply getting an accelerator. It's asking for accelerator and getting accelerator. So it's accelerator service. You ask for IPsec, you ask for video transcoding, just get it. In the first two cases. In the third case, it's FPGA itself as a service. You're providing a region of FPGA as a resource which the VM can use to do its own programming and do whatever it wants. Yes, there are security concerns about that. So the mechanisms to do the programming should go through some centralized agency. It's going to apply policies and security. That's true. But there's a general model where the user says, just give me a region, I'll do whatever I want with it. Right? Okay. So how do you model this? So this is the cyborg architecture from Harvard. In fact, even put your name in there. so this is standard which you all know about. Oh man, this is still messed up. Sorry about that. That's fine. I'll just talk you through this thing. So here are the NOVA components: resource provider, resource class, and traits. Here are the FPGA components like FPGA device itself, regions, accelerators, region types, local memory, and so on and so forth. So FPGA is a resource provider. So it's nested within your compute host resource provider. So it fits in the existing model. Each region within the FPGA is also a resource provider, which is nested within that. Right? So it's all modeled the same way. Every type of accelerator, like IPsec, for example, would be a resource class. And you may have 5 instances of that in the cluster. Video transcoding is another resource class. You got 10 instances of that so far, and so on. A region type is also a resource class because VM may ask for that. It may say, just give me a region of this type, I'll do my own programming. I've got the bit strings for that.
Wait.
Yeah.
When you say a region type is a resource class,
I'm sorry?
when you say a region type is a resource class, you mean that's something you can actually consume?
Yeah.
No.
Yes, you can consume. So let's say FPGA has two regions, A and B. I could say A is of one type, B is of another type, right?
Sure.
But
okay. But that's a capability.
It's a capability you can expose. A user in his flavor could say, I want a region of this type as a resource class.
I agree.
Okay.
I agree. The region itself is the resource class. The type is a trait of that resource class.
A resource class is one category.
A resource class, if you prefer, is an amount of things that you can deduce.
Yes.
Okay.
Right.
The fact that there is the fact that two different resource classes are different, are two different custom resource classes, if you prefer. That's okay. I think we basically agree on the fact that the region type itself is not a resource class. That's the accelerator, which is the resource class. But each region is a resource class. Each of those having a specific naming, I would say, which would be the type.
So let's say you got a host with two FPGAs. Mm-hmm. Each FPGA has two regions, A and B. So you've got A1, B1, A2, and B2.
Yeah.
So A is one resource class of two instances. B is another resource class of two instances. And you want to do it that way because the user may say that just give me that region and I'll do my own programming. Mm-hmm. So if you want a model where you're not consuming accelerators, but consuming just empty regions which you can do your own programming, you need to do this thing.
Okay. I don't want to go into too much details, but yeah, I just wanted to explain that when it comes into resource class, that's a unique amount of things that you can actually consume, and that's just my point I wanted to mention.
Yes,
but yeah,
that fits in here, right? Do you see any problem with this?
No.
Okay, cool. Okay, good. Okay, all right. Local memory is also a resource class. So different types of local memory, each will be a separate resource class, like HBM, DDR, QDR, whatever you call it. Right? The FPGA may also have some user visible features. I'll give you examples of the next slide. But those user visible features, which are not like consumable things, are modeled as traits. Let me give you a specific example of that. So one example is, let's say you got an IPsec accelerator. I don't want to take any old IPsec accelerator. I want to take FPGA is co-located with the NIC in some form. If the FPGA itself implements a NIC or is co-located with the NIC, there's some association with network there. Okay, so you will expose as a trait of that particular resource provider, and then the user could say, give me an IPsec on a resource provider with this particular trait. So you get the co-location. Okay.
Do you when you talk about that, do you also have neutron the neutron information on the NIC as well?
That's a very good question. I've not bottomed out on the neutron interactions. I'm willing to get input from all of you, but I think we need to kind of think through how cyborg and neutron will interact at some point, because you could have smart NICs with FPGA.
Well, at some point you could have a bare NIC that just says this is a NIC and completely unmanaged by neutron, or you could have it that neutron is aware where that NIC is plugged in.
The way I say it, if it shows up as a NIC to the system, neutron should manage it in terms of allocating ports and such, right?
Well, it depends. It really depends on the model of how you build your. If the FPGA outputs into the cloud, then neutron should manage it. If
But
the
it also depends on you run SDM or normal managed.
correct, and if the FPGA outputs out of the cloud, then neutron doesn't need to know about it.
In general, it'll be both. If FPGA is sitting with the network, it's processing packets back and forth.
Yes, but it depends on whether those packets go into or is part of the internal bits of the cloud.
Oh, I see what you're saying.
Or if the part of the, or if you can think of it as this NIC is effectively outside of the cloud.
Is the FPGA facing the host or is the NIC facing the host? That's your question. Yeah, we need to think through all of this.
That's where the neutron thingies are going to come in.
Okay, sure. We will keep that in mind. So that's the user visible portion. There could be many attributes which are not user visible. Howard is not here anymore, but I'll need to talk to him again later. One example of that would be some kind of a flag, which administrator was said that this kind of a high priority IPsec, don't ever reprogram that. I don't want it to be taken out ever. Just leave it as it is. So you may put out some kind of don't reprogram flag. This is not something the user sees. It's more like a hint to orchestration to say that don't ever reprogram this region. It's kind of locked down. Or you could take a region type and say that's always set aside for OpenCL kind of things. It's never programmed anything else. So that's one example. You could do all kinds of stuff with admin-only features. Like, for example, you could say that this FPGA has this JTAG version or associated USB ports, whatever you want. Things which are not user visible but administrator needs to know about. And so on and so forth. There are many examples of that. I do not think this feature is there today in cyborg. So actually more like a request to cyborg folks to add something like this. Okay. So I think it will be very useful for a general cloud operator.
Just thinking how these can map into the cyborg model. But well, I mean, because we have for all the deployables that is cyborg, it has a attribute table.
Exactly.
You can utilize those to put all of this information.
Exactly. That's what I was thinking.
It's up to the vendor how to interpret those attributes, right?
Yes, again.
Okay, so attributes of key value pairs.
Yeah.
We're saying that essentially some implicit key value pairs which are not exposed to no or anything else.
You're right.
Okay.
It could be totally customized by vendor.
Right.
And then during the extraction, it could be extracted out, and probably will only make sense to specific device or vendors.
Okay. Sure. Okay.
Yeah.
So this particular point, why wouldn't you put that region in the shell?
Why wouldn't you put, because this region is still made available. So for example, if it contains, let's say, an IPsec, you are still providing it to users, except you're telling orchestration never to reprogram it with something else, even if it's not being used.
That would still be a shell feature, because you can expose that functionality to, I mean, that's like, it's almost like it's almost like a non-PRable, it's almost like a non-PRable.
It's not PRable through orchestration, but you could do PR through admin only means. Administrator may still come and do his own thing. Maybe he's applying a better version of IPsec 2 weeks from now or whatever.
Right. And the only flow that's supported it is the shell flow, right? I mean, the administrator is not going to program the PR region.
Okay.
Just because
I
that's the user flow, right? So if you wanted to have that would be like the hardware. That would be like the hardware developer flow, right? Where you're actually programming the shell, and then the admin programs that unique shell. Presumably, it has a PF or VF, whatever, for that specific function that's passed through to the user, right?
Right.
And that is a kind of, if you will, static area that only the cloud administrator can then reprogram should they update it or deem it necessary, correct?
That's true, but it's also getting modeled as a resource class, right? So it's also exposed to Nova.
Yes.
Maybe I'm not following. This is shell feature.
No, I'm thinking of the FPGA now. So it's going to make it really complicated for us to have multiple different formats, like multiple permission levels in the vendor driver, right? Like, oh, this particular resource can't be reprogrammed, or this one can. We just need to. I think we would need to separate those out. We have a user space which can be reprogrammed by given the permissions set to that device. I mean, you'd have to set the user permission so that either the user can reprogram it, use it, or the administrator. It's like, so the vendor of the device, the owner of that bit stream, could be an individual, right? So it doesn't have to be the cloud administrator. They could program it. That's like an IP vendor. The user can then consume it. Right, as a resource class.
Sure.
But if you want to set aside like an IPsec device that's, say, provided by the cloud vendor itself, then that, I mean, it could be in the shell, or it could be as an IP vendor with restricted permissions on that image, right? Do you see what I mean? But I don't. There's this flag, this don't reprogram flag. That's slightly perturbing to me, because I don't think there's a good way to lock it down other than permissions.
Since it is exposed to the user, it will show up as a resource class, right?
Right.
Okay.
Yes.
So this region is showing up, or this accelerator is showing up, but at the same time, you need something to tell orchestration not to go about including in its regular scheduling policies to reprogram it. So if you want to call it a shell feature, it's fine, but at some level, it's exposed to.
I mean, when do you want it to be programmed? Do you want it to be always on, like, feature?
It could be programmed by administrator at his own level, but it's not programmed through orchestration.
Why wouldn't it be programmed through orchestration?
I think it would be programmed through orchestration, but you want to lock it down so the users can't rewrite.
So then you would just have a permission account that has the ability to program that bit stream. And when the user wants it, they get that programmed at runtime by orchestration, but they're not able to then reprogram it. They just are a user, a consumer of that function.
That's how I think, anyway.
This is only an example. We can talk more about this, but I'm not saying this has to be done. It's only an example of thing which could do that only properties.
But it's a valid example. I mean, you could have, I don't know what the shell is, but you could have some kind of firmware that you want to push to the devices, that you want to push to all the devices, or some certain devices, and you don't want the user to fiddle with that.
Sure. Yep.
And it could actually, since you're programming it from the outside anyway, you just basically just need a database that says that this shouldn't be reset.
Reset, yeah.
Well, yeah, and that's one useful. I mean, when you say firmware, the way I think about firmware is it is the shell. It is the region that when the FPGA boots in the first 100 milliseconds of the host life, or when you enumerate the PCI, it loads that from a flash region on the card. And that persists in a that's the management space.
But in this case, it could be something that
But that's more of like an IP level application in your FPGA. So that would be partial reconfigured into the FPGA at a certain runtime. But you could lock the permissions simply by user identity.
I am not sure there's a conflict between what you are saying and what I'm saying. That's what I'm trying to understand. It could be a shell-only feature, as you say, but it's exposed to resource class, and you don't prevent. I mean, you do prevent reprogramming. All three could coexist, right?
Yeah, I mean, there's multiple different ways to do it.
Yeah.
Okay.
I mean, I think you guys just talk about different approaches.
Okay.
Well, because as long as you're not locking it from the hardware level.
Yeah, we're not.
the same.
Right.
Either you set the flag in the user account, the certain level of users ability to do stuff, or you set the flag in the resource here that disallow people from doing.
Right.
Just take a look.
Yeah, so I mean, each user that develops a bitstream should have the ability to lock it so that it can only be consumed.
I think the Dutch way is more flexible in the future, and it's like it can open up this permission anytime you want.
Sure,
or
we
open up
can.
this permission to certain people you want without some fundamental change.
Like protecting a volume or a snapshot, basically.
But I'm also not sure exactly what the resource was. Anyways, we can pick this up. It's taking a bit of time, but we can talk about how exactly it needs to fit into this model.
Okay, sure. Okay, sounds good. Okay, so this is the basic initialization workflow. At start of day, cyborg enumerates the various FPGAs, regions, accelerators, and all in each compute host. From the host, it's propagated to the controller. The controller then updates the Nova placement API with the right inventory. So regions, accelerators, everything gets discovered and propagated at start of day.
Wait.
Okay.
That's the step 5 that I'm considering that. So the driver and the agent then gives information to the conductor that I got. When you say it updates the resources, it means that
it creates custom resource classes and resource providers to model
the
this.
inventories then. It creates the inventories.
Yes.
Okay.
Yeah.
Okay, and then you show up on the cyborg API what you got as well.
Sorry?
And so on the cyborg API, you also show what you identified.
Right.
Yeah.
I suppose, I'm not sure if it's there already, but it can be done, yeah.
Oh, you mean like suppose like you used to have a way to query it out what's available through the cyborg API, right? Is that what you mean?
Yeah. I'm thinking of whether so your agent reports the fact that you have 8 FPGA agents or FPGA types, agent types, rather.
Okay.
So you actually create 8 inventories. Each one of us, you create. You create basically 8 inventories for those 8 agent types. Different. Okay.
Each instance would be a resource provided by itself.
Yeah.
Each type would be a resource class.
Okay. I don't want to enter too much into the placement level because what I'm just saying is that you create inventories. That's fine. And then either you pop that up on the API by saying, for example, say I identify like 8 agent types, and here are my agent types.
Okay.
That's for the moment something that you don't have yet, right? You're not showing on the API
correct.
the number of accelerators that you found.
I think so. I don't think it's modeled this way right now. It's not modeled in terms of regions being resource providers and all that stuff today.
You mean in the cyborg DB?
The cyborg DB today, or even when you talk to placement API, it's not done quite in this way, right? This like it is okay. So modeling each region as a resource provider.
Right now we talk more about like deployables,
right?
And each region is also a type of deployable.
Okay,
you can consider it that way. So deployable is, you can consider deployable as a superclass we define the type, and then you can instantiate these deployables. But when they save it to the database, they're just one flat table.
Do we identify those deployables resource providers in placement API?
Yeah.
Okay, so it's already been
done.
Okay. Okay.
Like the deployables and resource providers are counterparts.
Okay. Yeah. Sounds okay. Cool. Okay. So that's done then. Okay. So pretty much existing stuff. So this is the API today. And my claim is that if you follow this model, the pre-programmed and user program model work exactly as it is. And I'll explain how. So let's say you got a request spec for, let's say, an IPsec accelerator as a custom resource class. Okay. So in that case, the request spec gets created. You pass through a scheduler. Scheduler talks to the placement API. It's going to look for all its resource providers and pick the right ones. It will return the RP tree, the matching resource providers back to the scheduler. And then you go through the filtering and weighing, all of the standard flow, make allocation. The scheduler calls in the placement API to make allocations for the chosen host and the chosen resource providers. It comes back, and eventually it goes to the compute node. The compute node gets a request spec. In a pre-programmed case, you are asking for IPsec, we just give it IPsec and you're done. So that entire flow should work as it is today.
So like you said, it's defined in the flavor. In the flavor, you have some kind of extra spec saying, okay, I want that specific custom resource class for that specific amount.
Yes.
Then magically, thanks to placement, it will create an allocation of that specific resource class. And at the end of the day, that's it.
Yeah.
Nothing will happen on the compute node side. Nothing. Correct.
Nothing needs to happen on compute node.
Sure. I'm saying that you are only sure with that if you care about your resource usage, you just have decremented your usage by 1. That's just what it does now.
Yes.
It doesn't give you any way to use that specific amount. It just consumes that amount by the number of amount that you requested on the flavor.
Sure, agreed.
That's it.
Yes.
Just reinforcing that.
Right, okay. On the compute node, it's up to cyborg to take the right PCA function, pass it to the VM, and make sure it actually gets assigned. The Nova has no role in that. That's what you're saying, right?
Well, Nova does the path-through, right?
But scheduler doesn't.
So the scheduler will make the claim. The scheduler will create the allocation. Okay. At the end, it will create an allocation against the specific resource provider matching with the compute node, so that at the end, when it comes to finding the compute node, it goes to the compute node, which has, fortunately, the resource class that you want. But that's basically it. You are just 100% sure that if you ask it for that specific resource class, you end up to a compute node that is having that specific resource class. That's just the guarantee.
But if 3 compute nodes can provide the same resource class, Nova scheduler does not tell which one of them is going to.
Sure. Well, yeah. It's basically pick the first one.
Well, the first one that picks up the queue work.
Well, it's up to cyborg to decide which one, right?
No. What I mean is, if there's 3 compute nodes that are exactly the same, and they provide the same resources, Nova scheduler can't say start with that one.
I think by default picks the first one, first host. The scheduler will figure out the depends on.
To be clear, I think that you have so you have then scheduling. I mean, placement will give you those 3 nodes.
Yeah.
And then you have filtering and whiting. And if I don't say mistake, based on the whiters, for example, it would like the less it will either as spread or pack policy based, for example, on the number of CPUs, because that's basically that's classic filtering and whiting. Because once you are done with selecting the 3 nodes that you care about, because those are having the FPGAs that you want, then how Nova picks one can be unrelated to you, because you only have the guarantee because that's only what you ask for. You only ask for an FPGA, and Nova will give you an FPGA. How Nova will pick that specific FPGA out of those 3 can be unrelated to your specific use case, because it can be because, for example, someone asks for anti-affinity on instances, or because he asks for he asks for I don't know. There can be a couple of factors that are way behind the FPGA thing, right?
Sure.
Is it okay?
Yeah. So filters and weighers could refer to non-FPGA criteria.
Yeah, sure.
Absolutely. So But at the end of the day, you're going to pick one node, right?
Yeah, sure.
And
But-
that's what you make allocation against.
Sure, but
Right.
I mean, there can be multiple ways also to pick out that you wish, like for example, by using aggregates. Say that, for example, if I have that specific flavor with that specific suspect that match some aggregate that having my specific metadata, then I can make sure that it can end up to that specific pool of hosts that are behind that aggregate. There are ways to trick the scheduler to go into a specific set of hosts, because there are some filters that can do that as well.
Sure. Okay. Sounds good. So here in the user program model, the user asks for region type. It says, I'm going to do it by my own program. Region type is a resource class, so it works exactly the same way.
Yeah, but you actually have to modify the flavors for it.
Yes,
Ah,
but it's a different flavor. But
Sure, but so someone has to, I mean, some operator has to write that.
why do that? Sorry.
But, Cyborg discovers that it creates some custom resource classes. You are still okay? Cyborg discovers the FPGAs and then creates the resource classes and the inventories. Okay.
Right.
Those are having like specific namings.
Right.
Okay.
Yes.
So in order to use those, you have to modify the flavor.
Yes.
So you probably have to ask Cyborg to give you the custom resource class names. So you can actually modify your flavor,
right,
to add the extra spec. Saying, okay, I want that specific resource class name,
right,
for that specific amount.
Yes.
That has to be a manual operation for them.
Yes, absolutely, sure, yeah. That's the user's request. Yeah, absolutely, yeah. Right. Okay. Cool. So I think we're on agreement for the first two cases, like pre-program, user program. Everything works fine with the current flow. Right. Now, when you go to orchestration-driven programming, it's a bit of a snafu here. So consider a scenario where the user asks for an IPsec accelerator. There is no free IPsec available right now. So in that case, you go through this flow. Placement API will say there is no resource providers can provide the resource class you're asking for. It's going to return an empty list of resource providers. The whole thing fails right here. So what should have been done is to recognize at this point that this is a FPGA. I can take an empty region, reprogram the IPsec, and then start using that. So that knowledge is not in placement API and Nova in general. That's where cyborg needs to come in. So we need some kind of a hook here to call into cyborg and say, do something about this now.
Well, I mean, in my opinion, Nova shouldn't have the knowledge of doing reprogramming.
Correct.
Nova should just ask Cyborg, give me this.
That's exactly what.
The Cyborg will go and, okay, shall we do reprogram, right?
Correct.
So Nova is just asking for this.
Yes.
And then it's up to Cyborg how to prepare it for it. And Nova shouldn't know, okay, I want to reprogram.
That's correct. Yeah.
Scope.
Right. That's what I'm saying. Right? This hook is for calling into cyborg.
Yeah.
Placement API only recognizes something has gone wrong. It's getting a lengthy list of hosts. Maybe because of custom resource class or whatever criteria you want, you could say based on this, I'm going to decide to call into cyborg.
So to be honest, you actually said the right word. This is an orchestration problem. This is an orchestration problem because if the user wants to get an IPsec accelerator and it gives you a valid host, why couldn't the user ask Cyborg, okay, but please give me an IPsec accelerator, and then Cyborg will probably make the modifications necessary for that, and then issuing the request again.
So the user tries this, it fails, then he goes to Cyborg as the next step and tries it again. It's a manual operation, right? How do you automate this in a cloud?
With an API. You have Cyborg API that you call that says,
actually, maybe we can call it one thing. Because if you talk of specific, let's say IPsec or video decoder, right? These are pass level. like P level.
This examples of resource classes, right?
No, I'm talking about platform layer and infrastructure layer.
Okay.
So if you're managing to Nova, right? Nova is purely ICE layer measures, right? It manages like CPUs, memory, and then right now, FPGA is also an infrastructure resource. You put it in there, you use it, you manage it. Now you want to load IPsec, you want to load video decoders onto those functions into the FPGAs. I think we should be careful about this because we don't want to mess up the P and I like too like.
The IPsec will model as a resource class, still a Nova level concept.
I know they're a resource class, but I mean there's no knowledge of past level functions. They're not like ICE level stuff.
So Nova doesn't know about IPsec per se, right? It only knows about custom resource class. The custom resource class A, custom resource class B. So I'm giving an example of IPsec. You have to call it A and B if you want. That's all Nova knows about.
Right. I mean, in my opinion, this flow is fine. In my opinion, we might want to use a separate set of API just dedicated for P level stuff, and a dedicated set of APIs for I level stuff. That's what I mean.
In a cloud.
So what's P and I in this case?
Infrastructure.
Yeah.
So I'm thinking this. When I think of an FPGA device, I think of the device. I think of the device ID of the FPGA. It is flexible and assigned by the shell, right?
Okay.
So you could have an IPsec device. That is a flavor, right? But the flavor then does not change by the user interaction with it. So if a user needs a new device, they cannot have it flashed at runtime, at request time, because that is in complete violation of the administration of the cloud. The cloud administrator needs to explicitly change that device
Yes, this
through their infrastructure management.
Yes.
So it's the P and I level stuff, I think, is what we're trying to make clear. When they want, if they want a IPsec IP, it needs to be programmed at user creation time through strictly cyborg, maybe, if that's what we want to do.
Yes.
In basically having a table saying this IPsec reprogrammable IP, this function, if you will, is compatible with this device.
Yes.
And can be programmed.
We're saying the same
by the
thing.
agent.
Absolutely.
I'm not sure we are.
This orchestrated programming, user is not doing the programming.
No.
OpenStack is doing the program. That's the whole case of constantly.
Here you're definitely asking to modify the infrastructure of the cloud based on a user request.
That's the essence of FPGA, right? FPGA is a reprogrammable device.
Sure, but you're asking Nova to do so, and not cyborg.
No, I'm not asking Nova to do it. All I'm saying is Nova calls into something which is able to do that.
No. I'm still thinking that you're asking Nova to modify that by asking cyborg if you prefer. But here the problem is that Nova should not make any assumption about changing something dynamically. Because, for example, also on the resource usage, you could just mess up the calculation of the resource usage, because here you will magically create a new resource
and consume
another one. So that necessarily has to be like a lockstep operation that you make by saying, okay, if for example I'm using cyborg in some kind of lockstep operation, I will make sure that cyborg will ensure that something is okay, I can have room for that, and then boot my instance. Because if I'm doing that now, which guarantee will I have that the reprogrammed FPGA will fit my user request and not any other user request?
It will fit my user request.
Yes.
This flows for, maybe I'm not following a question. It's for single request spec, right?
And then we'll busy loop.
Okay, maybe I should go through a couple of slides and then we'll revisit. I think I know what you're saying. You're saying you're asking for one resource but getting something else. That's the essence of your.
No, I'm saying you're asking to create the resource for you,
right?
But then your neighbor comes and takes your resource.
Yeah. So you have a race condition where someone else can take the resource you just created.
No, let me explain.
Parallel.
Yeah.
I think that does not happen.
Because
We
it's
will go through a couple of
it's
slides
a
and-
parallel timeline. Everything is parallel. Do you have a lock? Do you have
The lock
that
is
says, do you
the-
have a lock that says that you own that resource?
And please don't make a lock. I mean, here we're talking about a callback.
Yeah.
Here we're talking about a callback that will be introduced on Nova that will necessarily be like lockstep.
Yes. No.
So,
Okay.
So fail and create it.
no, I mean, I could be wrong, and I think that probably something has to be discussed with the World Nova community because I'm not like the only guy. But if you consider that, I want to have some specific resource that cyborg provides me. How can I guarantee that I will get that resource at the end? Because that's the whole purpose of the FPGA programming. You will ensure, you will make an SLA that even, because that's the whole purpose of FPGAs. If you're asking for any kind of hardware, that's not maybe not hardware, any kind of specific hardware enablement, FPGAs will give you that.
But it's also there's another thing here as well. It's if you ask for an IPsec device, you most likely want it to be connected. You want the FPGA to be connected to a specific network, and then you want the FPGA device. So that's your dependency.
That we already expressed with traits, right? Things like we saw the
But you
orthogonality.
also have to have the VLAN that's connected on the other side.
So look, like
If
for
it's a flat
IPsec,
network and if it's not, you
Okay.
need more configuration information. It becomes basically like a network device.
but the trait thing already handled that dependency portion. So okay, for now let's keep it kind of simple.
Even the possible VLANs it can connect to. Okay.
So the trait is a tricky one because with Neutron to describe a network is this amount of metadata, because it could be flat, it could be with VLANs, it could be in a tunnel, it could be with multiple ports. It's a whole object that describes a network.
It's a JSON object and it's a pain in the ass.
Yeah.
Okay. I'll note that.
That's if the network that it's connected to is managed by Neutron.
Right.
If the network is outside of the cloud, then it's effectively we don't care.
But then you also don't know which FPGA you'll be allocated.
You have no. Then you're dealing with that as like this is somebody else's problem. You tag.
And just to make it clear, you only know the port when you're on the computer problem.
Exactly.
Okay. So
And
we'll
not before placement.
we'll come back to this dependency thing in a couple of slides. Okay. In terms of the race condition, this thing, I think this is going to be race free. We'll talk through that also. There's a third objection, I think, from Dutch. Can you please remind me of your point again? You said something else about this flow. It's not user program, it's orchestrator program. That's what I'm alluding to, right? So the user is not making any changes by himself. It's only making a request.
So I think that, it's hard to summarize, but I think that the idea is that if you're defining what resource, like in IPsec, device at request time, and expecting that device to be an FPGA to be turned into another device and handed to the user based on the request to the scheduler, I think that's too low level. It needs to just say, the user asked for an FPGA device, here's an FPGA device, cyborg. Then cyborg says, okay, the user asked for this specific EUID of the RP, of the PR bit stream. Program it, then give it to the user.
Reprogramming is not done at this point.
No, that's something I really care about. I mean, if cyborg has the science of knowing whether FPGA is available or not, it can try to reallocate one specific FPGA to match with what the user wants. Then it can, that has to be discussed. It can it can, for example, pass, I don't know, a specific SHA-1 or UID or something that you can pass, I don't know, probably as a hint. Like saying, okay, if you want to use that specific FPGA, use that specific hint.
Right.
And then you could like doing this kind of external callback in a specific filter.
I think
Okay.
the essential is separate this entire flow into two sets of APIs. One is dedicated for allocating FPGA resource. The other one is changing the behavior of the FPGA to something the user wants. So to separate them.
From the OpenStack point of view, there is only one flow, right? You're doing something in Nova. User make the request.
Because
and
Nova only manages
generally
infrastructure, right? So
right.
Nova prepares this resource for the user. And if the user wants to change the behavior of the resource, they go to the cyborg API to change it.
But the user should not be managing individual devices. The whole point of the cloud, right?
Actually,
aggregating all the FPGAs and exposing it as a resource pool.
What you're asking is some resource reservation. What you're asking for is some resource reservation. You want to make sure that if you're making a request to Nova, you will get that specific reservation. And that is not something that Nova managed.
Okay. So let's do one thing. We'll go through one more slide.
Sure.
Make it more concrete. And if these objections still hold up, we'll come back and revisit this. Okay. All I said so far is we need something to do at this point. That's all I said so far, right? So okay. Here's one way to do it at least, which I think will kind of work. So at this point, the logic here is if there is no resource providers match the request spec, call it to cyborg and get a new resource provider list. That's all that's happening here. Whether it's happening here, schedule or what else, up to you guys. All I'm saying, somewhere in this flow, between these 2 points, call it to cyborg and get a new list of resource providers which can match that request. How do you get that? Cyborg essentially looks at that request spec. Because you asked for IPsec, I don't have it, but I got this region type which matches that. So it's going to return the list of all hosts which contain that region type. Essentially, got an updated list of resource providers. That's all it is. It fits in the same flow. Cyborg is working the same model, but giving an updated list of resource providers.
It's like asking for your second choice.
Exactly, pretty much. So you got an updated list, which it's not empty anymore. Behind the scenes, what's happened is you ask for IPsec instead of getting some other resource class region type, which can be transmuted into IPsec resource class. But no one doesn't know any of that stuff. It made a call, it got back a list of resource providers, moving on. And it works exactly the same. You apply other filters, other layers, your vCPUs, RAMs, whatever you want to do. All those things still happen the same way.
Basically, you have a factory, and when you're out of goods, you ask the factory for more.
Yeah.
Yeah, I mean, I think I see where you're coming from, but I think it's also, I think it's backwards of what we need to be approaching it as, right?
Okay.
So we need to approach it as not from the perspective of, you know, we need this thing, you know, do we have it or do we need to make it? Basically, it's kind of what you're saying.
Right.
I think from the perspective that we need to come from is we have this, let's change it into the, you know, we have this device. At the point when it's handed off, we can do with it what we will. When you hand it off to the cyborg to reprogram it or do whatever, it becomes what you asked for, what the user asked for.
That is true, but that the programming does not happen right here. Because if you do the programming right now, you're essentially picking one host.
It should never go out and say, I request this resource, I don't have it. It should always go out and say, I want FPGA X. And then they say, yes, FPGA X is there, or device, board, whatever is there. Either give it or it's not there. And, you know, we can't give it.
Yeah, well, actually, one way to tackle that would be to consider all FPGAs as equal as themselves. And say, I don't really care. I mean, from a Nova standpoint, I don't really care about which specific type of FPGA I want. I just want an FPGA. And then at the end of the process, what the user will get will be an FPGA that could probably not match with the type that he wants, but then it will be its cyber responsibility to make sure that it eventually matches.
Well, and that's, I think that's too low level, because now Now we don't know if our user functionality can be mapped to that FPGA.
Sure.
Because there's multiple, you could have different FPGAs, different size, different whatever.
Yeah. And the objection I have, or the thing that sort of rubs me the wrong way, is you're asking for a Mercedes and it's giving you a Ferrari. So it's, yeah, I know what you mean, but
Make the
it's,
Ferrari to Mercedes, then drive it.
well, it depends on what the thing is. But you're asking for one thing, and it's giving you, it says this is just as equivalent.
Right.
You know, I was when we actually started to discuss at the very beginning of the afternoon, I was having a very different workflow where I was saying those things are like Cinder volumes, where we could like say, okay, please create me some kind of FPGA resource that I want, and then I will do a late bind, like say, when I'm going to boot the instance, I'm going to bind with that specific FPGA. Right. That's something I was thinking for because cyborg has the knowledge of which specific type of FPGAs, has the knowledge of all the specific instructions that the user wants. So say I'm a user, I want to have one specific FPGA. I can just like ask cyborg, okay, program me that specific FPGA. I don't really care where, but just give me a UID. And when I will like boot the instance, I will provide that specific UID so that in a late check, I will have that specific FPGA attached to my instance.
Let me clarify one thing. For most people out there, they're not dealing with explicit devices. They want an accelerator. Their application requires IPsec, or machine learning, or video transcoding. That's what they're interested in. Most of the people don't develop their own bit streams and start deploying that.
Yeah,
so by and large, you're not going to ask for FPGA number 2.
Sure, but okay, the business model, if you prefer the business model of translating user needs into some specific FPGA stuff is definitely a cyborg thing. It's not another thing, right?
Yes.
Okay.
Right.
So if the user wants, for example, I want a pony, then cyborg will identify the right FPGA to be able to create a pony. Then, in my mind, the user could get that specific UID, and then we could discuss with another community on how we could attach that specific UID to make the pony available for the instance.
The idea is you before you even start the workflow over there, you create a cyborg object that describes exactly what you want. It's not allocated. It's not taking out a placement or anything.
Well, my own opinion is that it should be allocated, but not available to the user, and then attach that to the instance.
Yeah.
Like again, like Cinder, like neutron ports, like.
But in this case, you also this limits which physical host you want.
Correct, but that works exactly the same as with neutron ports.
Yeah, but it doesn't work the same as with
Sure. The analogy has some limits.
Yeah. So neutron port is a better analogy.
Yes, sure.
Neutron won't spawn an instance, or Nova won't spawn an instance if the neutron network is not available on the computer.
Yeah, exactly. So they need some kind of method.
And the same you get neutron and Nova won't spawn an instance if cyborg is not local to that computer node, or the cyborg resource that you want.
Well, that's probably where we need some kind of scheduling mechanism, because I agree, you have to end up to the right compute node that matches with the FPGA. But I'm not sure this is something we should be doing by placement, by creating an allocation, because just thinking out loud, and I could be wrong, if you're creating the allocation, like again, my analogy with a pony, okay, I continue on that one. So cyborg creates me a pony, gives me a UID. I don't exactly know where that pony is located. But when I will pass that on the user request, and for that we have, for example, scheduler hints, then somehow in the process, you will not need to modify the flavor.
Okay.
Just use a regular flavor for your instance.
Mm-hmm.
But given you pass a scheduler hint, you could imagine some kind of, I don't know, specific filter that you could add, a specific scheduler filter that you could make a callback to cyborg by asking, okay, for that specific host, are you okay with it or not?
Yes, that's already one of the filters we call in the cyborg.
For PCI pass-through, that's handled with MetaData instead. You add a filter for it.
PCI pass-through's got that FizzNet tag.
Well, that
but as a MetaData tag, and then you add a filter for it, so that no one knows which host.
The PCI pass-through filter.
Yeah.
That would be one way to consider that. You could imagine some kind of.
So it's like a MetaData tag and a filter for.
Well. You could actually, probably instead of doing a callback, you could using some kind of PCI information that you could give to the user, like the cyborg API could say, okay, if you want to use that specific PGA, just pass that information to the root, and then cyborg would modify indeed the PCI pass-through whitelist to make that happen, so that if you use the PCI pass-through filter, then you will end up in that specific device. That's definitely would be way better than a callback to the cyborg API, I think.
Yeah, and the only other thing then is if you could have a metadata UUID in the end, so you don't have to have the PCI pass through as such. So in a further development in the future, you could have identifying metadata entity, and then you have a filter that matches those, because you can have multiple versions of the same FPGA and multiple hosts, so you don't have to have the same, because the PCI ID can actually differ.
Sure. What I just want to be clear is that the cyborg API gives some kind of metadata instruction.
Yeah. To
the user.
To the
user.
Okay.
To the user. And will modify the for example, if on the post request asking for FPGA.
Yeah.
The outcome would be some kind of boot information that the user will pass.
Yeah.
When doing some PCI,
like PCI pass-through.
Yeah, like PCI pass-through, and then make sure that the PCI pass-through whitelist on that specific compute node is okay with that.
Yeah.
So that given that in your installation instructions you ask to enable the PCI pass-through filter, then for free you will get the mapping in between the PCI device and the user request.
Yes.
So I
because
think
you keep wheels, so you don't redo them.
You don't reinvent because because that's basically a PCI device that you that you need.
So it's just a question of how you identify them and how you make sure that they're critical. That's the biggest.
Yeah, but if you make the allocation to placement, then it gives you a compute node, right?
Yes.
Or if this is using nested resource providers because you have a rich model.
Yeah.
What you need is to have the root provider of that specific FPGA that you have.
Yeah.
So it will give you the compute node.
Yeah.
And so you can actually get the PCI ID and in order to configure that specific compute node to match your request.
Yeah. So let's take a step back at the usage model, right? We're a cluster or a cloud. Users coming along says, just give me an accelerator. I don't care how you do it. He does not know about the devices and the details or any other hardware. He may not even know there's FPGA in there.
Doesn't have to. That's the point. You ask cyborg to say that I need an FPGA, and it gives you an ID. You put that ID into your request to Nova, and now you have the host. Now you have the server with the FPGA and a VM on that machine. Next step is that you tell cyborg, program this with these things before you actually start up the VM.
But this whole notion of give me a device first, that's not a cloud model, right? When you launch a VM, do you say, give me a Mellanox NIC first before I put the VM up?
Yeah, this is exactly how it works. Yeah, that's how it works behind the scenes.
You actually put the flavor, you put a VNIC type or whatever, right?
Yeah.
And then it goes to a single flow. It doesn't come back to the user and you have to retry again.
Yeah, you put the flavor acts as a filter. So that's the first thing you do in the entire host list.
Exactly. So the equivalent thing here will be the flavor expresses the IPsec. the user wants IPsec, he says,
Yeah,
give me
but-
IPsec.
Yeah, but should you be stating that? Should you be stating the app you want to run, or should you be stating that you want an
Actually-
FPGA?
Can I add something here? So I think we basically talk about the same thing.
Yes.
What you're saying is how the user is looking at it. He's asking for.
Yeah.
He's from
Service.
orchestrator. He's asking for IPsec. I mean, from your point of view, I think what happened is, so behind this, how the things really happen behind the scene.
Yeah.
So in your flow, you ask for the FPGA, and then to Nova, and then you pass some extra information to cyborg, ask for the function. But I think the more appropriate way is to separate this by, okay, you have Nova here, and then you have cyborg on the side. Right? So from the orchestrator point of view, okay, I'm asking for IPsec. The orchestrator will first go to Nova, give me the FPGA, right? And then Nova give it back allocate the FPGA, give back to the orchestrator. And the orchestrator then make another separate call dedicated for pass level function, and then to cyborg, ask cyborg, just load this functions for me.
Wait.
In that case, instead of happen in a sequential
Yeah.
model, it happen in 2 calls.
Yeah, but you also have this thing where so you need for IPsec as this is the fetish of the moment. You'll ask for a machine basically. You'll say I want the machine. So I want an FPGA that I can run IPsec on. I want the machine that's connected with the FPGA to this network, most likely. And then you'll push that into Nova, and you'll get a host list back, and you'll take one host basically.
Yeah.
And then the next step is then that you have to say that I wanted IPsec, so deploy IPsec on it as well.
Right. So it's 2 separate steps.
Yeah,
From
well-
orchestrator, but
There's no guarantee though that the FPGA
Three
you've got will actually run the IPsec.
No.
Yeah, but
Well,
that's
that's where cyborg needs to make sure that.
Yeah.
That's actually where I diverge from you, because if you're asking cyborg, give me some specific IPsec FPGA.
Yeah, but you won't ask it that. You will actually ask you that class of FPGA in this case.
Okay,
So
so I'm not a specialist on that.
no, neither am I. So that's
So what I'm just saying is that it's up to cyborg, because he has the view of the available resources, to say, okay, I can see there is an available FPGA because there is some allocation on that. Oh, there is something that I haven't identified, is that we could probably need to keep track of the fact that the FPGA is attached or not, because you can actually that's another thing.
yeah, exactly.
Shit.
Exactly.
So explain me this. I want an IPsec. It's just an IP, right? But an IPsec thing. It's in the database, right? I ask for it. I say I want this function. I'm a user inside of I'm spawning an instance, right? It has to go somewhere and say, here's the IPsec I have. It's one thing. It's a square peg. I have to go find a square hole to put it in.
Mm-hmm.
In my cloud, I have triangle, round, square holes, right? How does it know that its peg will fit into one of the 3? It has to hit something first and say,
Yes. That's the
Yeah,
job
what
of
is the
cyborg
device
hook
ID
here.
that's compatible with this?
Yeah,
So in this first cyborg hook will do that. Basically, given this request spec, it's going to say you ask for IPsec. Instead, I got these region types. Let me see if there are any image which matches that region type and also gives this function.
The region type to me is a foreign concept. I think we just need to say device. So for me, it's a device. It's
Okay.
Vendor ID, device ID, subsystem ID. This is how I think of these devices in the cloud. And they're in general, right? So it goes and says, all right, I have this IP. I want to put it on this device. I go get the IP from my database. It shows here's the IP UUID, right? This is the thing that's translated by the user request. What shell do I have that's compatible with this? And that shell has a direct mapping to the device that it can be programmed, that it is programmed with it.
That
Yes.
the question has to be answered by cyborg.
Yes, absolutely. That's why I call it a cyborg here.
Again, I mean,
But how can you return an FPGA device to cyborg. What if cyborg says, no, this is the wrong, I don't have a bit stream that has IPsec that can go on this device?
No, but you ask cyborg first, and it tells you like.
Okay, so,
So
that's what I was
basically-
asking. So hit cyborg first.
Yeah,
cyborg
cyborg
asks
first.
Nova.
You hit cyborg first. I mean, the SLA, the contract, if you prefer, the end user contract would be, as an end user, I want to use IPsec and IPsec stuff. So I will ask cyborg, give me some kind of hash or ID or PCI stuff or any stuff that I can get. If I'm getting like, sorry, no, that means that my cloud cannot satisfy my request. But if I'm getting an ID, I can use that specific ID, and I think the implementation detail could use like the PCI pass-through mechanism that we have on the Nova boot.
So the reason that would not work, or I think it would not work, is that if you ask for one, you get that. We got 100 other criteria about how many vCPUs you want, how much RAM you want. It may not match those things.
No.
That's why you have to go through the whole flow,
Yeah,
right?
but you ask cyborg for your device, and it will give you an idea that it identifies these kinds of devices.
When you ask cyborg for a device, it just tells you that it
This
might be
hash.
possible. They might be on this cloud, this resource. It doesn't say it's possible to boot. It just says that
There are devices. So
Yeah.
basically, it gives you some kind of hash that identifies these kinds of devices uniquely, and then in Nova you give Nova that kind of hash, and Nova tries to match that to a host.
That's exactly what's happening here.
No,
Yeah, no,
in
no.
terms of workload, no, because here you're asking to have a callback within Nova, within the scheduling process to dynamically reconfigure your cloud, which is way more different than something like, as a user, I want to ask a specified API
Okay.
where I can give some ID that I can pass to Nova in order to create my instance.
so
This is way different in terms of.
it's different because this is requiring atomicity, and if it requires that some things are atomic, and whereas if you split it out, that cyborg does it first, then it doesn't require that. It's atomic.
Yes. And also you could even say that you want a bit stream with the functionality IPsec, and they can say I support these devices, or I have programs for these devices, and then you get those your IDs. So then you can ask Nova for all of those, and you can get one.
In effect, what you're asking first, if you do the cyborg thing, is you're asking it, build me a filter first, and then you're asking it, Nova, boot this and use this filter. And then Nova will tell you, no, this resource isn't available. Or Nova will tell you, yes, this is available, and let's go boot the thing.
Or you can actually boot an instance and do a plug of a specific PCI device.
If it's on both on the right machine.
I don't think you can do that.
Yeah, you might be booting it on the instance and asking it for a hot plug on something that's not connected to that specific.
Yes, exactly.
By the fact the physical locality is very much.
That's where you need to do the affinity stuff. So.
Yes.
Sorry guys, I definitely need to leave, so
Yeah.
have a good talk.
See you.
So to give you an idea, when we're doing network with Mellanox and Metronome, when we're doing offloads, the steps are you create, or a neutron port gets created. That neutron port does not consume resources. You can create